Welcome to Study Loop.
Hi friends, as shown in the diagram, there is a space probe having the weight of 3000 pounds and radius of gyration kx, ky, kz, and its value are given. Its initial angular velocity is 0. If a meteorite having the mass of 5 ounces is striking to the panel of the probe at point A and penetrate to the other side without changing the direction, only magnitude gets reduced by 25%. If final angular velocity of probe is this, we have to calculate kinetic energy of the probe after impact. It is also given that change in velocity of mass center of the probe along x direction is minus 6.75 inch per second. Let us start doing it. Mass of the space probe m dash weight divided by acceleration due to gravity. So it will be 93.17 slugs. Mass of meteorite m 5 O's upon 16 into 32.2. So it would be 0.009705 slugs. Position vector of point of impact A or A will be 9 I cap plus 0.75 K cap fit. Initial linear momentum of meteorite mv naught is equal to 0.009705 into Vx I cap plus Vy j cap plus Vz k cap. Now, any moment of momentum about origin initial. So, initial angular momentum of meteorite about origin will be Ra cross and V naught. M is constant, so you can take outside of determinant while solving the cross product. I cap, J cap, K cap 9.750 Vx, Vy, Vz. So on solving it, this value you will get 0.009705 into minus 0.75 b by I cap plus 0.75 bx minus 9 bz j cap plus 9 by k cap. Say this is equation number 2. Final linear momentum you can find. Since 75% is lost, so it will be 0.75 mv naught. So when we take 0.7, only this quantity will change. So it becomes 0.007279 px I cap plus by j cap plus bz k cap. So final angular momentum of meteorite about origin. This is not and this is final. So Ra 0.75 and we note all quantity will be the same, only this quantity will change by 0.75 times. So you may write 0.007279 minus 0.75 b by I cap plus 0.75 b by minus 9 bz j cap plus 9 b by k cap. Initial momentum of the probe is 0. M dash B naught dash, it is 0. Final linear momentum of probe M dash B dash. So it can be written as 93.17 0.675 upon 12 inch. It is given in inch. So we are converting it. dz k cap. Final angular momentum of space probe H A dash M dash k is kx square omega x dash ky square omega y k dash z square omega z. Substituting the value, we can write to be m dash 93.17, kx dash is 1.375 whole square, omega x dash is 0.05 I cap. I have forget to write I cap, j cap, k cap plus ky 1.425 whole square minus 0.12 j cap 1.250 square omega z k cap. So this can be written as 8.8075 I cap 22.703 j cap plus 145.58 omega z k cap. Now applying the conservation of linear momentum, point 009705 Vx I cap plus Vy j cap plus Vz k cap is equal to final linear momentum of probe and space meteorite, both 0.007292 Vx I cap Vy j cap plus Vz k cap plus 93.17 minus 0.05625 I cap V dash by j cap plus V dash z k cap. By solving the above equation, we can find Vx for coefficient of I. We can write 0.002426 Vx minus 5.2408. So Vx from here you will get minus 2160 feet per second. For equating coefficient of j cap 0.002426 Vy is equal to 93.17 Vy dash, say equation number 5, k cap point triple zero double zero two four two six Vz to be equal to 93.17 Vz dash. Now conservation of angular momentum, we can write conservation of angular momentum. Initial angular momentum of the meteorite point triple double zero 9705 into 0.75 V by I cap plus 0.75 Vx minus 9 Vz j cap plus 9b by k cap. That must be equal to final angular momentum of the meteorite plus space probe, so 0.007279 into minus 0.75 b by I cap plus 0.75 bx minus 9 bz plus 9 b by k cap plus 8.8075 I cap 22.703 j cap plus 145.58 omega z k cap. So equating the coefficient of I cap k cap, you will find minus 0.0018195 by is equal to 8.8075. So from here by you will get minus 4840.5 feet per second, and if we equate k cap, you will get minus 0.02183 b by is equal to 145.58 omega z. So from here omega z will be minus, I am writing directly, you need to substitute this value, radian per second. Now kinetic energy of probe related to its mass center. T dash half I x omega x square omega y square I z omega z square, which can be written as half m dash k x square omega x square ky square omega y square k square z omega z square. Substitute the value. M dash is 93.17, kx is 1.375 whole square, omega is 0.05 omega x, ky 1.425 square, and omega y is minus 0.12 square, kz 1.250 square plus omega z minus 0.726 square. So on solving it, the final kinetic energy of the space probe is 39.9 feet into pound. That's all for it. Thanks for watching it.